everyone, and welcome to another JASP video tutorial. In this video we are going to take a look at some data and run the descriptive statistics function on that data. Here you can see the splash screen for JASP. I am currently using the JASP 0.10 preview release version, so everything that I do in here is based on that. So let's go ahead and get started. Now, I opened a data file already, recent files here, and so I'm going to go ahead and open that data. This is data. If you have watched episode 2, link in a information pop-up card in the top right corner of your screen. Hopefully I can get that figured out. I'm not entirely sure how to do that in YouTube yet, but I see a lot of people do it. In any case, this is real data from about 2014 that I had while I was in graduate school, so we are going to go ahead and use this data set to run our descriptive statistics. To get started, you got to get the data open, obviously, and we just go up to descriptives and we click on descriptive statistics. This will change our view. It will bring up two new screens. The first screen on the left is the function window, which gives you the function that you are going to run, which is descriptive statistics. All of your variables, whether you want to run them or not, on the left. The variables that you are going to run your descriptive statistics on get put into the white box here on the right. And if you wanted to split by a categorical variable or ordinal variable, you can go ahead and put it into this box here. And so before we get started into these two drop-down menus, I want to explain where the output will flow. Here on the right side of the screen, this new window on the right side of the screen. Now, you can resize either of these screens. You can pull your data here if you want, and it drags everything around. You can close them. You can press these arrow buttons to snap open all of the different views. If you have a huge monitor, you can have all three of them open at the same time and see everything. I'm running a small window here in 720p, so you can just see a portion of it, but that's okay. Alright, for this video, we're just going to run descriptive statistics on pretty much all of these variables, regardless of what they are. And in the episode 2 video, I went through each of these variables, these categorical or descriptive variables. Age, not really a categorical variable, but I didn't go over these variables. Now these have silly little names, and these variables are from the base rate neglect task. Over the past 15 years or so, used in a variety of studies to see whether or not people can detect a conflict in stereotypic information when presented against base rates. And you may be familiar with this from all the way back to Tversky and Kahneman as the lawyer-engineer problem. So that's what those values are. I have response time for each of the three kinds of problems, and then I have their accuracy score for each of the three problems. So we are going to run descriptive statistics on that. So I'm just going to grab everything except for the subject, which is honestly just to indicate who is who. And as you can see, just by doing that, the default statistics from this drop-down menu, statistics, are plopped into the output. Okay, and we're going to have to scroll back and forth because I have a lot here to show you. We don't need to look at all of them, but but I will scroll just in case we find something that we like. So, by default, JASP has chosen statistics, descriptive statistics that are, generally speaking, the ones that are useful for quickly looking at what is going on in for a particular variable. So that would be the mean or the average for that variable, the standard deviation or the average distance any particular score is away from the mean. And then we have a minimum score and a maximum score. Those are the defaults. For every output, JASP also puts valid. So these are the rows that are valid. Okay, that the value for the statistics that you put up can be assessed, and the missing row here in this table, which is identifying any missing values. And of course, this is a clean data set with no missing values. It was clean 5 years ago, so there are no missing values. Okay, so I'm just going to add all of the descriptive statistics, and it'll show us in this table. So I'm going to add in the quartiles. These are the 25 percentiles. There's the 25th, 50th, and 75th percentile for each of these variables. We can do cut points. It is, by default, the values for 4 equal groups, but we can change that to 10 equal groups if we wanted to. And that'll, instead of the 25th, 50th, and 75th percentile, it'll give us the 10th, 20th, 30th, 40th, all the way down to the 90th percentile. I can do percentiles as well, and here you can specify which percentiles you want. So I'm going to put in some random ones, and you can put in as many as you want as long as they are separated by commas. So I'm going to do the 13th percentile, the 27th percentile, the 56th percentile, and the 88th percentile. And if I click that, it'll throw those in there, and JASP will let me know what those values are all the way through. Okay. Moving on to central tendencies. So this tells you the middle of the data set, where the meat is, where the scores might be. Okay. So we have the mean. This is the average, as you may be already aware. Then you can check the median. This is the middle value of the set. It's the exact midpoint of the data set for each variable. So here you can have a value there. The mode, the most frequent value in each of the variables. Now, if there is more than one mode, JASP will put a small little a here, and that's just a footnote value, and then puts down here that footnote, more than one mode exists, only the first is reported. Okay, so if you see that value, or if you see that little asterisk there, you can be assured that some of these values are only one of multiple modes. So if there is only one mode, then you're fine. If there is more than one mode, only one is going to show here, and you actually have to explore your data set to find out, and your variables to find out which are the modes. Sum, you can also check the sum. Okay, it'll show up here. This is the values all added together. It's not necessarily useful for a lot of things, but if you wanted your sum for a variable, you can go ahead and check that box. Okay. Now, dispersion, or variance, or variability of your variables. So like I said, the standard deviation, minimum, and maximum are the default values, and you can see them here, standard deviation, minimum, maximum. So there's these other ones, okay? So we have the standard error of the mean. So this is, or just commonly referred to as the standard error. So this value is the standard error of this mean. Okay, so where this mean would fall on its sampling distribution of this particular trace condition variable, which doesn't really make much sense. But let's say this the incongruent accuracy score, so 0.55. So it has a standard, that 0.555 value or 0.56 value has a standard error of 0.04. Okay, so that it's fairly small standard error. So that's the variance of the mean itself. Standard deviation is the average distance a single score is away from the mean, and that's a standardized value. We have the median average distance. So this is the average distance away from the median. Interquartile range is useful for finding the values within the 25th to 75th percentiles. You can get the full range, which is a single value telling you the maximum minus the minimum, or from the lowest score to the highest score, and what that number constitutes on the scale for the particular variable. Okay. So for incongruent accuracy, the lowest score was 0.16. The maximum score was 1. That means they did perfect. And so the range was 0.8. Variance, that is the standard deviation squared. So you can put that up if you need to report variance. And that is the variance 2. And then you can compare that to the standard deviation, 782, and do square root, square, whatever you'd like on that. Okay. Distribution. This tells you the quality and shape of each of the variables' distribution in your sample. Skewness tells you how much of a tail you might have. Standard error, so we have skewness and standard error of skewness. And this generally tells us whether or not we have a normal distribution or not. If we have a tail, perhaps outliers are causing the mean to be pulled away from the median. Because if you have a normal distribution, then the mean and the median and the mode are all going to be equal. But with a skewed distribution, you end up having some outliers that are pulling the mean away from that median and mode. And here you can see that negative values, and we have negative values and positive values for that. Now, kurtosis tells us how sharp our distribution is, whether it's tall and pointy or short and fat, and how much of the probability for scores are in the tails of the distribution. And this value is generally compared to 3, which is the kurtosis of the normal distribution. And so you can see these values are compared to 3 in either direction, negative and positive. I'm trying to see whether or not I have a good kurtosis value here, and I do not in this data set. Closest one here is a negative 2 or 3.96. So, issues with it, but it tells us where issues with some of these variables, but it gives us a description of where our distribution is going. And finally, our last statistic that we can get for descriptive is the Shapiro-Wilk test, which tells us whether or not our random sample that we got from this data set, these people here that constitute the values in these variables, came from a normal distribution. And so here's Shapiro-Wilk down here, and we can see whether or not this W value indicates whether our sample is normally distributed or not. Smaller values here on the Shapiro-Wilk test indicate that our random sample is not normally distributed, and we can reject the null hypothesis that our sample came from a normal distributed population. So if I look here, I don't think I have any issues with that. Oh, these birth and hand. Well, we all already know that handedness is not normally distributed. Response times are quite large. Okay, so that's the Shapiro-Wilk test for descriptive statistics. The other thing we can do in descriptive statistics is go ahead and get all of these different kinds of plots. Now, I've gone ahead and checked all of these plots. I had to do them in a slower order just to make sure that JASP didn't crash with all of these plot makings, because these are a lot of variables here. So I went through and I did them, and we're going to go ahead and scroll through. Now, here are the distribution plots, and for variables that are of the appropriate type, you can also add the display density line, which is this curved line here. And so on my average congruent accuracy score, you can see the different kinds of scores and so on and so forth. For categorical variables, it does not give you the density, and for categorical and ordinal variables, it does not give you the density. I could have changed age here to a different variable type in it, and it would have given me the density curve underneath that, because that is just crying out for it right there. But that's not a big deal. And so you can see here, then I have my RT scores. They kind of look a little normalish, and this one looks a little bit better, and that one is there. Okay, so those are all the variables. I can also do correlation plots. And correlation plots are only really useful for continuous variables. So some of these displays don't look all that great because of how the categorical variables align with the continuous variables. So we don't pay attention too closely to it. But what the correlation plot does in JASP is it will display it like a correlation table. So we have trace condition by trace condition, and so it essentially puts the distribution plot in the one diagonal. So in a correlation plot, trace condition by trace condition would be 1. There would be a nice big fat 1 here. It just puts the density curve in there. Now, as it goes along, you can see that scatter plots then are created, and when you get to a situation where there is a reliable correlation going on between certain variables, then you get a regression line put in. You can essentially see the shape without having to run any correlation statistics, which are found under the regression menu here. And so you can quickly find strength and direction from your correlation plot and your correlation matrix. So the correlation plot and the distribution plot are sort of redundant in the sense that density curves and density plots are given for the diagonal of the correlation matrix. Finally, we have the box plots. You can have a couple of features here for box plots. You can have just a traditional box plot. You can have it label outliers or not. That's useful when you quickly want to see it you can have the color of the box plot. Now this is automatic for JASP here. It's this reddish color. And I have selected the box plot element, the violin element, and the jitter element. If you are curious of where this information comes from, it's from the R package ggplot2, where you can play with a number of different fun visual aesthetics for a number of different plots. So let me go ahead and take, I don't want to take that one. Let's take age, for example, and we can take a look at how the elements in the visual. I don't recommend using all three visuals at the same time because it gets a little messy. You're more than welcome to do whatever visualization works for you. This would have to be cleaned up in another program. This is quite hard to read, but it gives you a quick indication of how your variables and the data within variables are distributed and where those scores are. So the box plot element is the traditional box of the 25th percentile and the 75th percentile with a middle line for the 50th percentile. So we have our IQR represented within the box. And so you can see that now the tails themselves represent various the below the 25th percentile and above the 75th percentile, and whether or not there are outliers, and those are indicated by labels. So this 44, this 20, this 35, etc. The violin element is what is pink. This is the shape that is given for the number of scores in a particular region of the percentile ranges. So a wide jut out means there are quite a few scores there. A small jut out, like say here, is a small number of scores. So the violin just gives you a quick visual for how many scores are at a particular place in the distribution. The jitter element separates the scores at a particular location. So you can see that there are more scores here because they are slightly off center from each other. So they're not overlapping. So the jitter element separates the circles for each individual score so you can see more clearly that there are multiple scores there. So here on which variable is this? Incongruent accuracy, we can see here that there are quite a few scores in the 0.6 to 0.8 range on the accuracy. So that's clearly a jitter. If I didn't have the jitter element active, I'm just going to unclick it here. It's going to overlap those, so you won't see those scores. So, of course, this cleans up the violins and box plots quite a bit. So having jitter there can help you, again, visualize where scores are in data. And finally, the last thing I want to show you on descriptives here is frequency tables. I got rid of the plots, so I left the table of descriptives. I got rid of the plots, so JASP didn't freak out at me. And so I'm just going to click on frequency tables, and this gives you the numerical values for each of the values in your variables. So, for example, trace condition, there's 1, 2, and 3. Those are the only values that exist in each of the rows for that variable, and it tells you how many there are, the frequency of them, the percent of the total, what is valid, so if you had any missing or issues with that, and then the cumulative percent. So we go 30.2, and then we go 30.2 plus 39.7 gives us 69.8. Then another 30.2, and we have 100%. So that tells you, these frequency tables give you more information on each of nominal and ordinal variables. So it does not give you that information for these scale variables. And that's going to do it for this video on descriptive statistics. I hope you enjoyed this one and give you a little clarity on how to do descriptive statistics in JASP. If you have any feedback, please leave that down below or catch me on Twitter. Thanks for watching. Bye.